Welcome to today's video. We're going to look at some more lightning skills. So this is making your indices much quicker, and we're going to do this with integration to start with. So integration, let's do a really easy one to begin with. Hopefully this is pretty easy for you. So the idea is going to be we're going to keep everything the same, and we're going to increase the power by 1, which is now going to become a 3. And as soon as we do this, we are normally taught to divide by the new power. But we're not going to do that, and you're going to see why we're not going to do that. So instead of talking about dividing by 3, we are going to think of multiplying by the reciprocal, and it's going to make our maths much quicker. So there we go. That's the first one. You might not see the point yet, but keep going with it for a little while longer. Let's do the next term. So the next term is plus a half x. If there's nothing there, that means that there's a 1. So this is now going to become a 2. And again, we're going to do a half times by that one there. The next one, we could, if we really wanted to, think of it like this, and this increases by 1 and we divide, but we're not going to do that. We're going to just leave that one as 2x, okay? So let's just do it like that so we can see that. Don't forget our plus c, and now we simplify, okay? We need to be simplifying the vast majority of time on these questions. So a quarter x cubed plus a quarter x squared minus 2x plus c. So let's have a go at some more examples where this really proves its usefulness. This one here has a fraction, so these ones are a lot more annoying. If you imagine 5 over 2, it's going to go to 7 over 2. Dividing by 7 over 2 is not going to be very nice. Think about it. Yeah, it's possible, but you don't really want to be doing that. So let's do a half x to the 5 over 2 becomes what? Becomes 7 over 2. So we're going to think not as dividing by 7 over 2. We're going to think as times by 2/7. So let's just do 2/7 there at the front, okay? Much quicker. So 1/7 x to the 7 over 2, for example, is the first term. The others are quite nice in this one. How about this one here? Let's have a go at another one. So which term? Well, maybe the one there in the middle. So 3/5 x. What would happen to the minus a half? It would now become, wouldn't it? It would become a half. So let's have a think. Dividing by a half. No. We're going to say then timesing it, multiplying it by 2, aren't we? Okay, so something like this would be the way to do it. So that's going to be 6 over 5 x to the half. Quickly check your answer. If you differentiate it, a half of 6 is 3. That answer's looking pretty good. How about you have a go now? So on the next one, let's say it goes something like this. You're not going to say this. You're going to say this one here instead. Pause the video and have a very quick go. So how does it go? It goes something like this. 3 over 4. 3 over 4 plus 1 should become a 7 over 4. So this one is going to have a 4/7. I'm going to slot it in like that this time. Next, let's do 3 over 2. I mean, that's a pretty nice one. Let's just do it while we're here, though. So that's going to become a squared. So that's going to be, well, yeah, a half. Okay. That looks like a trickier one there on the end. So let's do this one here. It's an 1/8. It's minus 5 over 4. That's like minus 1.25. Okay, so that's going to become a minus 1/4. And multiplying by the reciprocal, that's going to be just multiplying it by minus 4 over 1. Okay, so what to do to finish? I suppose we could tidy these up a little bit. So that looks to me like minus 2/7 x to the 7 over 4. That's a 3/4 x squared. You can do something with this 4 and this 8. So what's that? There's a minus in there as well. So minus a half x to the minus a quarter. Okay, yeah, of course, plus c on all of these. So I hope I've convinced you there that thinking instead, multiplying by the reciprocal can really speed up these kind of questions. Here's another one on the list of what students pretty much get stuck with. It's when you've got whole numbers and fractions, and we're going to use a bit of a trick. So, for example, if I said to you x to the 2/3 was 4, and I asked you what x was, one way that we could do this is we could use the reciprocal power on the outside, on both sides, to tackle this, because that way you're effectively getting x on its own, x to the 1, x. So what is 4 to the 3/2, for example, where square root first is 2, cubed it's 8. So we're going to use this kind of trick, okay? So if we have something like, this is just made up, something like this one here, what we're going to do is we're going to use the reciprocal power on the outside to eliminate that and get what we want all on its own. Let's have a go. So this one here, now I could divide by the smaller power on both sides first. Just careful when you're doing this, you're actually eliminating a possible answer. Here, let me show you. So if I move things to the same side, notice we can factorize this one out. Okay, so it is possible that x to the 3/2 could be 0. Okay, when you get these questions where you have the same thing on both sides, it's possible for that thing to be 0. You see this a lot in trig questions like sine x. Let's do something like sine x equals sine x cos x. A lot of people cross those out, you know, and sort of solve what's left. Well, you can do that, but you've got to remember that the thing that you're dividing on both sides could be the bit that made the equation work. Okay, so on this question here, it's possible that x could be equal to 0, but we're going to explore with the other case. So let's jump into it. We're going to divide by x equals 3/2 on both sides, the smaller power, and that's going to give us x to the half equals 4. Well, if we use the trick that we just talked about, squaring on both sides, that's going to mean that the answer is x equals 16. Don't forget, what did we do? We divided through by something that's in common, so we should just put or x equals 0. So it depends on the context of the question. Maybe they're going to say that the thing can't be 0, but it could be. So there we go. Let's do another one. So here, notice again, if x equals 0, this is going to work, because 0 equals 0 makes that equation work. What other answers are there? Well, let's divide through and find out. So I'm going to divide by x equals a half on both sides. 3 take away a half is 2.5, or 5/2. I'm going to get the numbers on one side. And now I'm going to use that trick that we did from earlier. So what power on both sides would satisfy this to make it x? It would be 2/5. That would work. So our final answer is going to be x equals 8 to the reciprocal power 2/5. That's not going to be that nice of a number. X to the 2/5. You can write the 5th root of 8 squared or something like that. I'm going to just leave it as 8 to the 2/5. So have a go now at putting into practice what we just talked about with these two questions here to see if your indices work has sped up a little bit. So let's jump into it. Here we go. 5/6 x, the new power, is going to be 2/3. Watch out for that. It's not 1/3, it's 2/3. We're going to multiply by the reciprocal. of the new power. It's all about the new power. So 3x to the 3 times a third, and then minus 2/3 x plus c. Let's do a bit of tidying up. So that one there is going to leave me with a what? With a 2. So I think I get 5 over 4 x to the 2/3. Over here, that's just a 1x cubed minus 2/3 x plus c. There we go. That's how we would integrate this one with respect to x nice and quickly. Over here, so notice that because you can take out x to the half and it leaves this situation, the x bit again could be 0. Or you can just test it by saying, 0, take away 9 lots of 0 is 0. So it definitely works. So x equals 0. And let's investigate some other solutions. So if we divided it through, we would get x to the 1.5, that's 3 over 2, minus 9 equals 0. Let's move the 9 to the other side. And let's use that trick. So 3 over 2, the reciprocal is 2/3. So x equals 9 to the 2/3, which again is not necessarily a nice number. So we have x equals 0 and x equals 9 to the 2/3.